Hello, ladies and gentlemen. Welcome to another video. Today, what we're going to be doing is we're going to be talking about one-step equations, specifically ones that we're going to solve by using addition and subtraction. So you might be sitting there saying, well, what's a one-step equation? How do I do this? We're going to walk you through that. The first thing I want to talk about, though, is a balance, okay? What does it mean to keep things balanced? So when I think of a balance, normally that means that you have the same amount of things or things that are weighted equally on each side. So for example, if I had 3 items over here, so 1, 2, 3 items, I would also have to have 3 items over here in order for them to stay balanced, in order for my scale not to tip one way or the other. Well, if I think of it that way, what if I were to remove something from one side of my scale? So let's say, for example, I went over here and I said, you know what? I want to get rid of this. I don't want this here anymore. Is this balanced anymore? Not really. This side's going to be heavier and it's going to start leaning towards that way, okay? So how do I make it balanced? Well, the way I could do that is by also removing one from this side. Basically, what I do to one side of my scale, I need to do to the other side to keep them balanced. If I removed one from here, I would need to remove one from here as well, and I could keep doing that as much as I want. Let's say I wanted to add one. Let's say I added one to this side, okay? Now let's say I had 2 to this side. Now I have 3 over here, okay? How do I keep this balanced? Well, it's going to start leaning that way. So to keep it balanced, I'd have to add 2 over here. This sounds like common sense. You're probably looking at this going, yeah, Mr. Guy, like I can understand that. I can get that. Well, that's what we're going to be doing mathematically when we go to solve these equations. Whatever we do to one side, we want to do to the other to keep them balanced. We do it to one side, we do it to the other, okay? So let's look at an example here. So here we have x plus 5 equals 15, and I want to solve this for x. Basically, what I'm solving for is, what does x need to equal to make this equation true? And the way we're going to do that is by using our one-step equation, by keeping them balanced and doing the same thing to each side. Now, some of you may be able to look at this and say, Mr. Guy, the answer is 10. 10 plus 5 is 15. That's what x would need to be. And if you can do that, that's great. However, we're going to be adding a lot of different stuff to these equations as we go. So we want to make sure that we know a way algebraically to do it so that when they get more complicated and we can't just do them in our head, we have a set process that we can use. So how do I solve this algebraically? All right, well, here's what we're going to do. The first thing we're going to do is we're going to make sure we identify what the 2 sides of my equation are. So in this case, I have the x plus 5, and I have the 15. The equal sign is kind of like the middle of my scale to keep them balanced, okay? Then I want to say, all right, my goal is to get this x by itself. If I can get the x by itself, I can know what it equals. I can know what it is. So the thing that's with my x right now is this plus 5. So basically, I want to ask myself, how do I get rid of an add 5? How do I get rid of a plus 5? And that's where we start thinking about our inverse operations. What is the opposite of adding something? Well, the opposite of it would be subtracting. Those are the inverses of each other. So what I'm going to do is I'm going to subtract 5 from over here to get the x by itself. Now remember, we talked about that scale earlier. If I do it to one side of my equation, I need to do it to the other as well. So the plus 5 and the minus 5 are going to become 0. They should equal 0. Adding 5, subtracting 5 equals 0. So on this side, I'm left with just x. My equal sign will carry on along down with me. And then over here, 15 minus 5 equals 10. Hey, those of you said that x would equal 10. That's what we got as our answer. Now, the work that I showed is really important so that somebody else can come and look at this and see, oh yeah, this is how you get that x equals 10. But what's also important is I need to check my answer. Let's make sure that this answer is actually correct. How do I check it? Well, in order for it to be a solution, it has to make my equation true. So let's plug it back into this equation and make sure that it actually makes it true. So I'm going to do my check step, which involves me taking this 10 and plugging it in for x. So I'm going to rewrite that first equation, except instead of writing x, I'm going to replace it with a 10. And then I'll go ahead and do any sort of math that I see that I can do. So here I know that 10 plus 5 is 15. And then once I simplify that, I want to ask myself, is this a true statement? Does 15 equal 15? It's kind of a dumb question, right? Does 15 equal 15? Yeah, it does. That means I can put a check mark here, check step, this works out, x does equal 10. That makes it true. Here's another one. We have r plus 4 equals 16. I'm solving for r here. We're going to do the exact same thing again. We're going to say, all right, how do I solve for r? What's the opposite of adding 4? It's subtracting 4. We're going to subtract 4 from both sides. And so over here, 4 minus 4, that equals 0. Those are going to cancel out. I'm going to be left with just r. Over here, I have 16 minus 4, which is going to equal 12. And there's my final answer. Am I done? Am I good? Can I move on? Oh, wait, I almost forgot. I have to make sure I do my check step. Let's check it and make sure it actually works. I'm going to rewrite that original equation, except instead of writing r, I'm going to replace it with what I said r equaled, which was 12. And I want to make sure I get a true statement. Well, 12 plus 4, that equals 16. So I'm getting that 16 equals 16. Well, stupid question. Does 16 equal 16? Yes, it does. Check step. We're good. That works out. So r is going to equal 12. Again, you're going to be required to show your work for all these problems. Make sure you see exactly how we want it laid out. We want it to be neat so we can follow through and see all the steps, especially when we start adding on even more steps. This is a one-step equation, meaning it only has one step. Add or subtract the number is what we're looking at today. All right, but eventually we're going to add in more steps. We want to make sure we're being really neat when we go to solve these. I want you all to go ahead and try these 3 problems I have here. I want you to do exactly what we just did. So add or subtract to solve for whatever the missing variable is. We have t, m, and y you're going to be solving for. So pause the video, try those 3, and then come back and we'll check our answers together. All right, and we have our answers here. So for the first one, I subtracted 7 from both sides. I got t equals 2, checked my answer, and I got that 9 equals 9, which is true. For the second one, I subtracted 11 from both sides, got m equals 9, checked it, 20 equals 20, that one's good. The third one was a little weird. You might have had some issues with. I went ahead and subtracted 8 from both sides. 5 minus 8, well, it just means that you're going to get a negative answer. So remember, same sides add and keep, different signs subtract. Okay, so we have a 5 and a negative 8. That's really like 8 minus 5, which is 3. Take the sign of the higher number, which was the 8, so it's going to be negative 3 is my answer, right? I have $5, I have to pay 8, now I owe $3, okay, negative 3. I went ahead and checked that. Negative 3 plus 8 equals 5, and yeah, so 5 equals 5, and that one is true. So next thing we're going to be doing is looking at, again, still one-step equations, but this time that number is being subtracted. Oh, weird. So how do I do that? Well, all you have to do instead is think of what's the opposite of subtraction. Oh, wait, we just talked about it. Subtraction and addition are the inverse operations. So in this instance, I'm going to be adding 8 to both sides. So let's add 8. Let's add 8. And in this one, I'm going to get that g equals 20. And again, I'm not done until I check my answer. So I go ahead and I check it. In this case, I'm going to say, all right, well, let's see. If I have 20 minus 8, does that equal 12? And it turns out 20 minus 8 does equal 12. And 12 equals 12, so I'm good to go. My check step is good. So again, in this case, we're going to be adding instead of subtracting because we're doing the opposite operation, the opposite thing to get rid of that number. Okay, for this one, same thing. We're going to be adding 3 to both sides in order to get this s by itself. So I'm going to add 3, and I'm going to add 3. So over here, 3 plus 3 is negative 3 plus 3 is going to be 0. So I get an s. Over here, I have a negative 15 and 3, opposite signs, same signs add and keep, different signs subtract. So 15 minus 3 is going to give me 12. And then I take the sign of that higher number, which was the 15. So my answer is going to be negative 12. And again, I can check it. Let's go ahead and check it. Negative 12 minus 3. And we're going to see, does that equal negative 15? Well, if I owe $12 and I owe 3 more, or same signs, add and keep, 12 and 3 together is 15. And I keep the sign, negative 15 does in fact equal negative 15. Check step, good to go. All right, I want you all to try these 3 problems. Here are 3 problems involving subtracting that number. Again, how are you going to solve them? You're just going to add that number to both sides to get them by themselves. Go ahead and try those for me, and then meet back and we'll check them together. All right, and here we have our answers. So let's look. For the first one, I added 7 to both sides. I got that h equaled 16. Double checked it. 16 minus 7 does equal 9. I'm good to go. For this one, I added 11 to both sides. Negative 32 plus 11. Same signs. I keep different signs subtract. 32 minus 11 is 21. And then I keep that sign of the higher number, so it's negative 21. Checked it. Negative 32 equals negative 32. Good to go. This is also where this check step can be really helpful if you have issues with negatives. And who doesn't have issues with adding and subtracting negatives? If you get the wrong answer here, this will tell you got the wrong answer. You'll know every time, oh, I got it wrong. Let me go back and check it and fix it. I must have done something wrong there. Probably where I added my negatives. Over here, added 8 to both sides. W equals 33. Checked it. 25 equals 25. Good to go. The last thing I want to talk about is the different ways that these equations can show up. Sometimes we look at them and we go, oh no, it's not exactly look like x plus or x minus. How do I solve it? As long as you have an x and a number with it, you can do this process in terms of the adding and subtracting. Sometimes we'll move around where they show up, but you still do the same thing. Like look at this first one, for example. It looks different, but really it's the same thing. When I go to solve this, I'll say, all right, what's with my x? Well, I see a negative 5, right? There's a negative 5 there. Well, what's going to get me to 0? What's the opposite of negative 5, of subtracting 5? Because negatives and subtraction are interchangeable. Well, the opposite of that is going to be to add 5. And you might say, well, Mr. Guy, I see a plus sign right here. What about that? That's with the x. The 5 is negative, so we're going to add 5 because that's the opposite. And again, we want to make sure we get to 0. We want to make sure these cancel each other out. And negative 5 and 5 will cancel each other out and make 0. So over here, I'll also add 5, and I'm going to get that x equals 17. And once again, my check step will help me with that. If I do my check step, negative 5 plus 17 equals 12. I got to make sure that actually equals 12. Well, negative 5 plus 17 is 12. So there we go. My check step works out. It all works. Okay, I'm good. All right, that's how I solve that. This one over here, now the x is on the right side. Does that change anything? No, it's still the same process. All right, I've got to get the x by itself. What's with it? There's a negative 8. There's a subtracting 8. What's the opposite? I'm going to add 8. And over here, I'm also going to add 8. And so I'm going to get that 15 equals x. And then, am I good? Well, let's do the check step. 7 equals 15 minus 8. What's 15 minus 8? Oh, it's 7. 7 equals 7. And there you have it, ladies and gentlemen. That's solving a one-step equation using addition and subtraction. Thank you for watching.